Okay, I'm aiming for 15 minutes. Hey, bloggers, shout out to Oscar, trying to keep it under 15 minutes. Let's see how this goes. All right, so I gave you these notes, and I actually gave you this one first, conditional probability. It starts with this, but we're actually going to start with the example because I think it's easier to follow what's going on with the example, and then we'll go back to proving it with a Venn diagram. So in a class of 25 students, 14 like pizza and 16 like iced coffee. One student likes neither, and 6 students like both. A student is randomly selected from the class. What is the probability that the student likes pizza? Then, that the student likes pizza, given that he or she likes iced coffee. Okay, so what we want to do when we have a situation where we've got a couple of things happening and there's some overlap, it's nice to draw a Venn diagram. Okay, so we're going to go ahead and draw a Venn diagram for this one. So I have my universal set is all 25 students. So this box has to contain all 25 students. And then I'm going to have some students who like pizza, and I have some students who like iced coffee, and I know that these happen to overlap. So this one I'm going to call pizza, and this one I'm going to call coffee, and there's going to be some overlap here. So the overlap is going to be 6 students that like both, so I'm going to go ahead and put that in there. And it also says that one student likes neither, so I'm going to put the one out here. Okay, they don't like either. So what is then the union of pizza and coffee? If there's one person who likes neither, then that means everybody else likes either one or the other or both. So that would be 24. So I know that the union of pizza and coffee, the union of that, the number of the union of pizza and coffee has to equal 24. Okay, the union of those two things is going to have to equal 24. So from our law with addition, which is also in our formula packet, okay, oh no, it's not in the, yeah it is, there it is. It's called combined events. This is our addition law. The union is equal to the probability of A plus the probability of B minus the probability of the overlap. Okay, we could show that actually works, right? So we could do 24 is equal to the number that likes pizza plus the number that likes coffee minus the overlap. Okay, so I'm just using this formula here. The probability of the union is equal to the probability of one plus the probability of the other minus the probability of the overlap. Notice I was using the letter n here because I'm just actually counting the number of people. I'm not actually talking about a fraction or a probability yet. All right, so does this work? So 14 plus 16 is 30, and 30 minus 6 is 24. Yep, so the union of this is 24, and then I've shown it also. I've got 14 who like pizza, 16 who like iced coffee, minus the overlap gives me 24. So there's got to be 24 in all of here. All right, I already know that overlap is 6. So I can get the iced coffee. I know there has to be 16. I already have 6, so there has to be 10 in this circle. Pizza has to be 14. I already have 6, so 14 minus 6 gives me 8. So there's going to be 8 people in that circle. Okay, and then all together, the whole thing, if I add these together, 8 plus 6 plus 10 plus 1, that's the person who doesn't like anything. If I add those together, I get 25. Okay, so now I've accounted for everybody. All right, so let's look at the first question. Probability that somebody likes pizza. Okay, how many people like pizza? There's 14 people out of a total of 25. So that's my probability of pizza. Choosing somebody who likes pizza. Kind of a weird notation there, P of P. So I probably should write P of pizza, so it keeps it clear. Okay, part B, it says, what is the probability that this person likes pizza given that she or he likes iced coffee? Okay, so this means I've already chosen somebody who likes iced coffee. So how many people like iced coffee? That would be 16. I've already chosen out of 16. I'm only looking at these 16 people because I already know that they like iced coffee. How many of those people like pizza? So of these people who like iced coffee, the people who like pizza is 6. And so that is the probability that they like pizza given, and here's how we write given that they liked the coffee. Okay, and I'm abbreviating coffee, iced coffee to just coffee. So this is what we call conditional probability, when you are finding the probability of something given that something has already happened. So we've already decided that we've picked a person who likes iced coffee. So we know there's 16 people that could have been, and then we want to know what's the chance that they like pizza. So notice it's not out of the entire 25. It's only out of the people who like coffee. Okay, so there is actually a formula that goes with this, so conditional probability. So if we look on our formula sheet, there's something called conditional probability, and here is the formula for it. So it says the probability of the intersection of these two events is equal to the probability of A times the probability of B given A. Okay, so now we're going to go back to the other page and see how this works out with a formula. But we just did it without a formula, and actually usually these problems are easiest done with just a Venn diagram or a two-way table, which we're going to look at later, and just looking at the situation. But of course, IB needs to make things difficult, and so they're going to like force us to use the formula at some point. So we need to figure out how to use the formulas as well. So let's go back and look at the actual formula. All right, so here's my formula. Given two events, A and B, the conditional probability of A given B is the probability that A occurs given that B has already occurred. All right, so like we had over on our example, that you get somebody who likes pizza given that they like iced coffee. So we have already selected down from the original group of people, we've already narrowed that down to a select group. Okay, and then we're trying to find like a second thing about them. So here's the formula. The probability of A given B, so this is like likes pizza given that they like iced coffee, is equal to the intersection of A and B divided by the probability of B. Okay, we can rearrange this by multiplying both sides of the equation by the probability of B. So if I multiply probability of B on both sides, then the probability of B would cancel out. I'd be left with the intersection is equal to the probability of A given B times the probability of B. Okay, so here it is just rewritten. So you can put this over here. So we can prove this using a Venn diagram. So the probability of A given B, we can look just right on here, and we can see how this goes. So the probability, let me move this up. The probability of A given B, we're just going to do it like we did on the previous example with our Venn diagram. So given B, so how many people like B? Well, that'd be B and C. So that's how many people I'm choosing from. So that'd be B plus C. And the probability that they also like A is just these people right here. Okay, so that's the probability of A given B. We can just look at our Venn diagram and figure that out. So we want to know, does that actually equal the probability of the intersection divided by the probability of B? So let's do that. So we're going to have the probability of the intersection of B divided by the probability of B. Okay, so the probability of the intersection is going to be, the intersection is just B. So what's the probability that we get one of these people? Well, it would be B divided by the total number of people. The total number of people in this situation, that would be like all 25 people over here with our pizza and coffee example. So I'm going to add all these together. It's all the people, A plus B plus C plus D. That's all the people. And then I'm going to divide that. That's my probability of the intersection, B over all the people, divided by the probability of B. Okay, who's in B? B plus C is in B. And out of all the people, A plus B plus C plus D. Okay, notice we've got an ugliness here. We got a fraction divided by a fraction. So I'm going to change that. I'm going to write that out as division. Okay, so that's the same as writing B over A plus B plus C plus D divided by, I'll write it this way first, B plus C over A plus B plus C plus D. Okay, so I've got my two fractions here. Now when I divide by a fraction, I change that to multiplying by the reciprocal. So keep the first fraction, A plus B plus C plus D. I'm going to go ahead and put that in parentheses so they all hang together, times, and then this is going to flip. So I'm going to have B plus C on the bottom, and then all of these on top, A plus B plus C plus D. Can you see where I'm going here? kind of hard and fell into the crack there. Sorry about that. So notice I've got A plus B plus C plus D in the numerator and the denominator, so I can cancel those out, and I'm left with B over B plus C. So we have now just shown that, yes, this formula can give you the same thing as just doing it directly. Okay, so in IB, there's always going to be situations where they're going to make you work with these crazy formulas, although it is easier to just do it how I did it on the original example. Okay, where you just make the Venn diagram and then pick your numbers off the Venn diagram. But here it is true, we've just shown it using a diagram. We can prove that the probability of A given B is in fact equal to the probability of A intersecting with B divided by the probability of B. They both equal the same thing. See that? They simplify to the same thing. All right, second example. How am I doing on time, Oscar? I got 4 minutes. All right, let's see if we can do it. Okay, in a class of 40 students, 34 like bananas, 22 like pineapple, and 2 dislike both fruits. Illustrate this on a Venn diagram. So I'm going to have bananas, I'm going to have pineapple, and I know 2 dislike both of them. So out here, this is my 40 people, 2 don't like any of them. So that means the union right here, the union of, what is this, pineapples and bananas? Bananas and pineapples. So the union, the number in the union of bananas and pineapple, that has to equal 40 minus 2, because there's only 2 people that don't like either. So that's got to equal 38. Okay, and we know from our addition law that this, the number of bananas union with pineapples, is equal to the number of banana-loving people plus the number of pineapple-loving people minus the overlap. So the number of people who love bananas and pineapple, the overlap. Okay, so we have 38 is equal to the number of bananas is 34. The number of pineapple is 22, and we don't know the overlap yet, so I'm going to call that x. And now we can solve for the overlap. So 34 plus 22, so 38. 34 plus 22 is 56 minus x. So I'm just going to do 56 minus 36. I'm getting lazy here. So 56 minus 38, and we get 18. So x is going to be equal to 18. All right, so my overlap is going to be 18. Once I know the overlap, it gets pretty easy. Bananas, I have to do 34 minus 18. Okay, so 34 minus 18 gives me 16. And for the pineapples, I have 22, so 22 minus 18, that gives me 4. And then I better check and make sure, does this all add up to 40? So I have 16 banana lovers plus 18 who love both, plus 4 who only love pineapple, plus 2 who don't like any of them. Whoops, and I made a mistake. Let's do that again. 16 plus 18 plus 4 plus 2 gives me 40. So those are my numbers. So notice how I use the addition rule to help me get those numbers. All right, so now that we have our Venn diagram, let's go ahead and answer these questions. A student is randomly selected. Find the probability that the student likes both fruits. Okay, there's only 18 people who like both fruits out of 40 people. That's it. Likes at least one fruit. So we want the people who like fruit or like both fruits. So that would be all these people. So we can add these together and we get 38. There's 38 people who like at least one fruit. These people happen to like 2, but notice it says at least. So that's going to include the people who like bananas, the people who like pineapple, and the people who like both. So I actually added those together. So let's write that down. How did I get that? I added all 3 of those together. That's how I got that. Okay, likes banana. Oh, I have 30 seconds left. Likes bananas, given that he or she likes pineapple. So we're only looking at the people who like pineapple. That's these 22 people. And how many of them like bananas? 18. Dislikes pineapple, given that he or she likes bananas. Okay, we know they like bananas. There's 34 people who like bananas, and they dislike pineapple. So these people like pineapple, these people must not like pineapple. So that's 16. And there it is, 15 minutes and 4 seconds. I'm done, Oscar. Good night.